Thanks for joining us today at HxGN TV. I'm your host, Neville Judd, and today we're discussing the HxGN SMART Fit solution. Joining me on my far left is Marcel Veldhuizen, who is Vice President of Business Development for Intergraph PP&M. And on my near left is Fabio Yada, who's Sales Manager for Hexagon Ventures. Gentlemen, thanks very much for joining us today.
Thank you, Neville.
So, Fabio, I'd like to start with you. Modular construction has been adopted by industries the world over. What would be the motivation for them to want a high-tech solution to managing that?
Yeah, the modular construction approach is being adopted worldwide, in different industry, and more. It brings a lot of benefits, like, for example, you can spread the construction in different sites, even in different countries. Right. In Brazil, for example, we have several projects that part of a plant or part of a ship it's under construction in China, and the final integration will happen in Brazil. Okay. So you can parallelize the construction, you save time, you reduce the quantity of people in the final site, the quantity of material. Usually the final site of a refinery or the final site of a petrochemical plant is in a very remote location. So you reduce the quantity of people during the construction phase. You save cost. And also is also safe to have less people in the final site of construction. And you can find some subcontractors that are specialists on this kind of models or this kind of fabrication. Right. It's more under control to construct that specific model in their site and not in the final site. Right. But at the same time, we start to create some challenges. For example, the final assembly and the final integration of all those parts. Right. The transportation of these big models, of these big structures, they are subjected to problems. Mm-hmm. You can have a deviation, you can have a problem during this transportation. All the lifting process, it's expensive process as well. All these lift equipments are very expensive. Usually the companies, they hand to this kind of equipment. Right. So with SMART Fit, you can predict some deviations, some potential problems that before you transport, before you lift, before you move these big structures. Right. So for example, I mentioned a project in Brazil. A mega block is under construction, a ship mega block is under construction in China, mm-hmm. and then this mega block will be transported to Brazil. Before you transport, we can measure this mega block in China. Mm-hmm. We send all these points, all these measurements to Brazil. Mm-hmm. We have a quality analysis over this mega block, and we also can perform a virtual assembly of this mega block before the transportation. So we can predict, we can make some correction before the transportation.
Are there any other, so I was going to ask you how SMART Fit fits into the process, and you've alluded to it. Can you elaborate any more on how else it might be applied?
For sure. Let's try to make a step-by-step process. So first, the engineering department provides you a CAD model, a 3D model of this structure. So this is the base for checking the quality. Right. Then, using this 3D model, which is a product from the engineering team, you start to plan your measurement work. Before you go to the construction site, inside your office, you use this 3D model and you start to select some specific points, some key points in the edge of the structure or in the key parts of the structures. And after you create this plan, you synchronize all these points with an equipment, a total station, for example. Right. When you go to the field, you already have the plan and the equipment, the total station synchronized.
Right.
When you are in front of the real structure, the constructed structure, you positioning the equipment, and then the equipment start to locate this point that you planned before,
right,
in an automatic way.
Okay.
More modern is your equipment, more better results you have. For example, if you have a robotic total station, the total station starts to move by itself, controlled by the software, to collect the points that you planned before. So this is the first step, to guarantee that the structure A, the quality, the dimensional quality of this part, it's okay. It's under the tolerance that you define. You predefine a tolerance that you can work, okay? This is the first part. The second part is to perform the virtual assembly itself. So you have the mega block A, you have the mega block B, and then you start to make the virtual assembly, and we provide in a real time a graphical report with colors, respecting the tolerance that you provided before to the software. So then you have the quality of the part is okay, the virtual assembly performed, it's okay, or maybe you have to take an action, and this action will be taken before you transport this structure. That's the point. So can you imagine tons of tons lifted, and then you need to take an action in the time above this
right,
lifted part, very heavy. So we are talking about safety as well.
Right.
Right? And what you are adding in all this process, adding some value on that, we are storing all the data that are generated during all this process. We are storing in a centralized database, and you are feeding back the potential deviations and the potential actions to the engineering team, to the planning team,
right,
and also to the materials team. Sometimes you need an extra material to make some correction.
Right.
We are creating a workflow, and nowadays what we see in the most of the construction companies that we visit,
right,
this dimensional quality control is very isolated from the other phase. The decisions are made in that time, in this for a mechanical correction or a welding correction, and not necessarily is the best way to correct that. So having this workflow, the right person to take the decision and to avoid future problems in sister structures, let's say, it's very important to have this feedback and
right,
this workflow completed. This is SMART Fit.
I see. Okay. Marcel, you're a marine industry specialist. How do you see HxGN SMART Fit fitting in your world?
Yeah. So as Fabio alluded to, shipbuilding is very modular as a basis. I think it's always comparable to Lego in that sense. But like Lego, there are multiple sizes of blocks that you can have. And you need to make sure that the blocks really fit nicely together in all of that. So what the shipbuilding industry has been doing since a long time is measuring all the deviations that are possible. There are a multitude of reasons why there are deviations, like Fabio alluded to. I need to lift something. And as soon as I lift something, there is a change in the form. Okay? If I have a different temperature, like today here in sunny California, I would say I have a different dimension than I would be on the North Pole, where it's freezing. Okay? So the material shrinks. So you need to take all of those things into control in order to make sure that in the end my product fits correctly and is up to the specification that the owner was asking for. So that's one of the key elements where we see SMART Fit come into play, because it is a continuous improvement of that process. That reality and the design that we initially started off with needs to be constantly updated as a loop, as such. That's what we see in the shipbuilding industry.
Perfect.
How do you see SMART Fit complementing the PP&M portfolio?
So as Fabio alluded to, a lot of the onshore powers are not built anymore at a single location. They are distributed all over the place. But in the end, as a main contractor, I'm responsible that everything fits correctly. Okay? And by having equipment done in China or parts done in Thailand, parts done in the Philippines, and I'm working in Australia, I want to make sure that before it arrives on site in Australia, it is up to specifications. So I want to do a check before I put it on the barge, if it's up to the specs, and I want to do a check when it's arriving and it's offloaded from the barge, so I can see what happened in between. So I can make adjustments at the right location, because you can imagine, for instance, if I do an offshore platform in the middle of the ocean, I don't have a lot of equipment, okay, or making corrections. I don't have the ability of all the tools that I have when I'm onshore. So those things is where you see Smart Fit really come in. I'm prepared that things fit with the actual situation, and I don't all of a sudden have a crisis situation where I need to fly in people, fly in equipment, because as you can imagine in the ocean, it's pretty expensive to have people on helicopters, ships coming by with special equipment, delays. So there's a lot of things that help and impact all of that. When we have Smart Fit, I can do a lot of work in advance. I can run the virtual simulations in my office, and I'm prepared when I come on site. Okay, and it's not I come on site and all of a sudden, surprise, it doesn't fit. And that's why we see a lot of things. And that's applicable for the power, oil and gas industry, nuclear industry, actually any industry that does a modular design that we have. And that's a perfect fit on what Intergraph PPM does.
Right. Gentlemen, thanks very much for joining us today.
Thank you very much.
Thank you, Neville.
We'd like to thank our guests, Fabio and Marcel, for joining us today. If you'd like to find out more about HxGN SMART Fit, visit hexagon.com. And to watch more episodes of HxGN TV, visit hxgntv.com. Thanks very much for watching.